Hello world. Today we're gonna talk about uh, something very interesting. This is about this. This is not a chandelier. Welcome to the quantum computing, quantum processing, quantum algorithm. This is the topic of today. What is that? A quantum? It's a Latin word, means how much, amount. And what you saw here as a chandelier, it's basically a refrigerator, dilution refrigerator with absolute zero temperature. When I say absolute zero temperature, we're not talking about Celsius or Fahrenheit. We're talking about Kelvin, which is about negative 273,135 Celsius. Like Celsius, not 0 Celsius, negative 273,000 degrees of Celsius. And Fahrenheit, pretty much the same. It's just about 35 points between Fahrenheit and Celsius. So what is a quantum computing algorithm? Quantum computing algorithm is the following. The current computers and the smartphone and all of those is built in a byte, which is 0, 1. We call this byte, classical bytes. For example, if you have a coin, it's a head or tail. So for example, head is 1, tail is 0, or vice versa. So it's all the computers you have, all the tablets, the phones, all as of now, it's a classic computing built in 0 and 1. The quantum computing is different. It's a qubit, which can be 0, 1, and other things. So if you look at this coin, you think there are two positions, either 0 or 1. But if you flip the coin like this, professor, if you flip it in the air, watch this again. I'm going to flip a coin here. When it's in the air, you didn't know it's a head or tail, 0 or 1. You didn't know that. So we call that a superposition. Superposition. And that's quantum computing, which is 0, 1, and superposition. So it's a next frontier exploring how quantum computing differ from classical computing, how it powers AI and it impact in fintech. That's what we're going to do now. As I said, classical computer is a byte, 0, 1. Quantum computing is 0, 1, and superposition. Here's an image. Explain the differences in the quantum computing or the classical computing and the things in the future you're going to hear about it. A simple example of the difference between classical computer or quantum computer. If you have 1 million bucks and and the key is one of the boxes, if you want to search in that, you have to go all the million bucks. If you're lucky, maybe in the first box, the key. It could be the second, could be all the way up to million. But with the quantum computing, you can use Grover's algorithm and will take you a square root of time of what takes here. Another example, suppose you want to build a gamble in your computer that with 25% gives you a payout of 2, 50% 1, 25% 0. As of today in the current computers, with all the AI technology and machine learning, all of that, the way to do it, it has to be built through two gambles. 1, 0, 50, 50, and the second gamble will be 50, 50. With the quantum, it will be one gamble of this, not two sequential gambles. So quantum computing and AI, and that's what we care about it. Quantum computing came after AI for a reason. The development of quantum computing way before, but it came after AI for a reason. And the reason is AI need a lot of information center. And the problem with information center, it takes a lot of energy, space, and this through cloud technology. You need a big farm to put an information center. With the quantum computing, you didn't need any of that. You just go to the chandelier. And here down the chandelier, there's a quantum computing, which is a small one like this. You put it here, and then you're done. To provide you complex simulation and deep learning. Implication in fintech, portfolio optimization will be different with real-time complexity. You can do it with quantum computing. Risk modeling with a fewer assumption. Quantum enhanced encryption. Block and shows, option models. So basically now we're moving from classical to GPU to quantum computing. Classical, usually Intel was the leader in this. GPU is NVIDIA, and through the GPU, we have the AI technology. The quantum computing, which is QPU, CPU, GPU, QPU. Now there is a race. IBM with NVIDIA. We'll see who's going to win. Key takeaways. Quantum computing is fundamentally different. Offers exponential speed up for select tasks, sorry. And still in early stages. We expect that technology to come in 5 years. The homework is the following. What is the difference between classical and quantum computing? And here I explained that. What is a quantum superposition, which is 0, 1, and then error? It's basically imaginary and a complex number. I'll talk about it later. What is a real-world example of comparing quantum and classical? What is a quantum computing considered the future? Why? It's the future of technology. Because we have a lot of data, we need the speed. What is an example of the impact of quantum computing and quantum algorithm in fintech? Like a Black and Scholes model. Today, like happened to be, this is a quantum computing I was supporting. I invested a lot in this computing. It happened to be the day I did the presentation, they just moved up 30%. They went up 30% today. So remember this company. This is the next NVIDIA, basically. The market cap for this company is a 5 billion. But if somebody's going to pass NVIDIA, will be one of those quantum computing. So I like this company, but I'm not a financial advisor, so it's up to you what to do. Thank you so much. Answer the question, and that's your homework. Have a good day.